So this assignment is related to the particle physics and the particle accelerator. That is the last topic of Unit 4. So in the first question in 2016, the element Ganassin was added to the periodic table. One of the isotope is given. Which row represent the number of the proton and number of neutron? So you can also use the chat to state the answer. If you want the number of proton, neutron, and electrons, to get the number of the proton, atomic number is representing the number of protons. So it is 180. So proton number is equals to 118. And to get the number of neutron, we take a difference. So when we take a difference of the two, it will be 294. The nucleon number, which is 294 minus 118. So it will be 176. So 176 neutron and 118 proton. So A will be the right answer. The next question, the particle has a mass of 3.17 exponent minus 27 kilogram. Which of the following mass is there in giga electron volt per c square? So first what we'll do, we'll convert this mass into energy, and that energy will represent in giga electron volt. And remember, energy in giga electron volt is same as the mass in giga electron volt per c square. So we have the formula, like we have the mass here. So we'll use the formula E is equals to mc square. So if we need the energy will be mass into speed of light square. So mass is 3.17 into 10 to the power minus 27. And speed of light is 3 into 10 to the power 8, and that is square. This will give the answer in joules. So like this answer will be there in joules. But what we want to convert into first electron volt and then to giga electron volt. And we have this 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we have this many joules, like 3.17 into 10 to the power minus 27 into 3 exponent 8 square, these are the joules, then x electron volt. So we cross multiply. So this whole factor will be divided by 1.6. So then this final answer, like 3.17 into 10 to the power minus 27 times 3 into 10 to the power 8 square divided by 1.6 into 10 to the power minus 19. So when we divide, this answer will be in electron volt. But we want to convert into giga electron volt. So how to convert electron volt into giga electron volt? As 1 giga electron volt is equals to 10 to the power 9 electron volt. So again, we'll use the ratio. We have this many electron volts are there. So 3.17 into 10 to the power minus 27 into 3 into 10 to the power 8 square. And that is divided by 1.6 into 10 to the power minus 19. Will be x giga electron volt. So when we cross multiply again, we have to divide. So the final answer will be D, the 3.17 exponent 27 into 3 exponent 8 square divided by 10 exponent 9 and 1.6 exponent minus 19. So basically, when we solve this, we'll get the energy in giga electron volt. And this energy is giga electron volt is same as the mass in giga electron volt per c square. In question 3, positron and muons travel at the same speed through a magnetic field. The magnetic field direction is into. So positron is a positive particle is there. A muon, because it's a lepton, a negative particle. So if we have a magnetic, first we'll identify the direction of the deflection, and then using their masses, we can work out, check the momentum. The one which is having a higher momentum, large momentum, means it will less deviation or smaller curvature, a larger curvature, radius of a curve will be. So magnetic field is into. So if the magnetic field is into, our index finger or first finger represent the magnetic field, which is point into. So the index finger or the first finger should represent the direction of the magnetic field. In this case, it should point into. And we'll use a left-hand rule for a positive particle. The second finger represent the direction of the particle. In which direction the particles are moving? The particles are moving up. This is the direction of the particle. Where automatically your thumb will point when you apply the rule. So where your thumb will point in this case, when you apply the rule, so your thumb will point towards left. So if the thumb is pointing towards left, it means that the positive particle will deviate towards the left. So if the particle is coming from the bottom, all the particles are moving up. So the positive particle will go towards left-hand side as the left thumb is pointing towards left. So muon is a negative particle, positron is a positive. So it can be A, it can be B. So either it can be C or D. Then when we check the deviation in a magnetic field depends on the momentum. The one which is having a lower momentum, like it will show a greater deviation or a smaller radius of the curved path. So when we compare the mass of positron and muon, as I mentioned, both are moving with the same speed. Speed is same, but because the positron is having a lower mass, so it will have a smaller momentum. Smaller momentum means smaller radius of the curved path, so it will deflect more. Whereas a muon, it's having a high mass, as a result, it will have more momentum. Greater momentum means greater radius of the curved path, or it deviate less in a magnetic field. That's why option C is the valid answer. In question 4, a neutron can decay to produce a proton. Which of the following equation correctly show a neutron decay? So whenever any nuclear decay occur or happen, we should check the conservation of the charge, conservation of the momentum is also conserved, but from equation you cannot conclude, like check the conservation of momentum. So from equation, there should be a conservation of the charge, lepton number, baryon number, and the strangeness. Lepton and baryon number, for each lepton it is +1 and anti-lepton it is -1. And for baryon number, for each baryon, each quark, actually it's a baryon number 1/3 and anti-quark is -1/3. Because proton and neutrons are made up of 3 quarks, that's why each is 1/3. So total baryon number will be +1. But the first thing, whenever you check, you start with a conservation of the charge. Like both sides, the charge must be balanced. When you check the first one, neutron is neutral, proton is positive, positron is also positive. So this charge is not conserved. Like one side, the relative charge is 0, the other side is relative charge is +2. When you check the second equation, neutron is 0, proton is plus, positron is also plus, so there is no conservation of the charge. When you check option C and D, both have the charge conserved. As you can see, charge is conserved. So both have, when we check the conservation of the charge, this is right, this is also right. The charge is conserved. Then we check the baryon number. Baryon number for each quark, the baryon number is 1/3, anti-quark is -1/3. proton and neutron made up of 3 quarks, so each is having a baryon number +1. So this is +1 baryon number, this also plus. Electron is a lepton, anti-electron neutrino is also a lepton. So they don't have a baryon number. So there's a baryon number conserved here. And this +1, there's no baryon number for lepton, so it's conserved. So baryon number is conserved for both equations. Then we check the lepton number. Lepton number for each lepton, like electron, electron neutrino, tau neutrino, or neon neutrino. These all leptons, they have the lepton number +1, and they all antiparticles have lepton number -1. So when we check the lepton number, because proton and neutrons are baryons, so their lepton number is 0. Electron is a lepton number +1. Anti-electron neutrino, lepton number -1. So left hand side and right hand side, lepton number is conserved. But what about this option D? Electron is +1 and electron neutrino is also +1. So means the lepton number is not conserved for equation D. That's why C is the right answer. So whenever you check the conservation, you start with the charge followed by the baryon number and then lepton number. And there is one more thing, strangeness you can also check, but that is strangeness is if there is a strange particle, like strange quark is there. Otherwise, you don't have to check the strangeness number. In question 5, a gamma photon is there with the energy of 18 mega electron volt, produce particle and its antiparticle. Which of the following will give the maximum possible mass of the particle in kilogram? So this is the energy is there, but energy should be in joules. Like we have the formula E is equals to mc square. So if E is equals to mc square, energy will divided by c square will be equal to mass. So we want to find the maximum, and this is called a pair production, like a mass, matter and antimatter is produced. So first, this is mega electron volt. We have to convert into joule. So 18 mega electron volt, because when we substitute in this formula equals mc square, energy should be in joules. So this will be 18 into 10 to the power, mega is there, so 10 power 6 electron volt. Then this electron volt, we have to convert into, but this is the total energy which is used to produce particle and antiparticle. Like if there's a photon, it produces one matter, another one antimatter. So half of its energy, like not all 18 giga electron volt will be, mega electron volt will be used. Only 9 mega electron volt will be used, because 18 is the total energy used to produce particle and antiparticle. But in the question, we want the maximum possible mass of the particle only, like one of them. So how we can work out the maximum possible mass for one? So the energy will be used, will be half of it. So it will be 9 into 10 to the power 6 electron volt. And then we have to convert this into joules using the ratio, like 1 electron volt equals 1.6 into 10 to the power minus 19 joules. So if we have 9 into 10 to the power 6 electron volt, this will be x joules. Cross multiply. So it will be 9 into 10 to the power 6 multiplied by 1.6 into 10 to the power minus 19. So this will give us answer in joules. So this is the answer of energy in joules. Now to get the mass, energy in joule divided by speed of light square, because the mass is equals to E divided by C square. So in energy in joule, that is 9 into 10 to the power 6 multiplied by 1.6 into 10 to the power minus 19 and divided by speed of light square, which is 3 into 10 to the power 8 and then square. So when we substitute, this will give us the mass of the particle. In question 6, in electron deflection tube, electrons are released by passing a current through a metal filament. What is the name of this process? Because electron can be released by two ways. One is photoelectric effect, another one is fermionic emission. What happens in a photoelectric effect when light in the form of photon having energy more than the work function minimum possible energy to remove electron, this electron will come out. That is called a photoelectric effect. Another thing, when we pass the current or we supply heat energy, these electrons gain sufficient amount of energy and will come out from the metal surface. What we call that as a thermionic emission. Like by the action of the heat, we are removing the particles. Ionization is in the atomic scale, like when we remove the electron from an atom, we call that as ionization. Like a charge, ions are produced as a result. But here already electrons are available within the structure and we are removing the electron from the structure. So there are two ways, either photoelectric effect or thermionic emission. Question 7, a particle has a mass of 3.4 giga electron volt per c square. Which of the following gives the mass of the particle in kilogram? Remember, as I mentioned, the mass in giga electron volt per c square is same as energy in giga electron volt. So what we have to do, like this particle will have the energy of 3.4 giga electron volt. So first we'll convert this giga electron volt to electron volt and then from electron volt into joules. And then energy divided by speed of light square, as we have the formula E equals mc square. So m is the mass, which is equals to E divided by c square. So the important part, we have to convert first this giga electron volt. So energy, which will be equal to 3.4 giga electron volt. First convert into electron volt. So it will be 3.4 into 10 to the power 9. Giga means 10 to the power 9 electron volt. And then 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So if we have 3.4 electron volt x joule, cross multiply. So we multiply by 1.6 into 10 to the power minus 19. So this will give us answer in joules. So 3.4 into 10 to the power 9 times 1.6 into 10 to the power minus 19. And then this will give us answer in joules. This answer in joules, what we will do, we'll divide by speed of light. Because why divide by speed of light? We need the mass. So mass is energy in joules divided by speed of light square. So it will be 3 into 10 to the power 8 and then whole square. So 3.4 exponent 9 times 1.6 exponent minus 19. And that is divided by 3 exponent 8 square. So option D will be the right answer for question 7. In question 8, the diagram shows the track of two particles P and Q which are created from original particle X. Which of the following can be concluded from the diagram? So what we can conclude from this diagram? At point X, you don't see a track. So if you don't see a track, what you can say about the original particle, you can say the original particle does not have any charge. Why I say like this, that original particle does not have any charge? Because original particle, the diagram shows a track of particle P and Q created from the original at point X. So original particle was a neutral particle, as the neutral particle does not give a track. So which of the following can be concluded? P and Q have equal and opposite momentums. Like the value of the momentum in P and Q, it's same. and but in opposite direction. The original particle has no charge. So when you see if one is moving towards the right hand side, another one is moving towards the left hand side. So their values of the momentum, but the curvature is not 100% identical. It's slight variation is there between the two curvatures. That's why we cannot say they have the equal momentums. And like we can say they have equal momentum, but we cannot say they have opposite momentum, because when opposite momentums are there, what does it mean in physics? What is the opposite momentum mean? It means like if one of the particle is moving toward the right hand side, the other should move toward the left hand side. But these two particles are moving. They have the two components, horizontal and vertical components will be there according to their motion. So their momentums are not opposite. They have equal, that's true. Like curvature looks a bit similar. That's why I can say they are equal momentum as a thickness of a track or the curvature is similar. But I cannot say it is opposite. Why? Because they're not moving in opposite. If they were having an opposite momentum, then this should be the case. Like the part when they produce, they should move in opposite direction. One is moving clockwise, another one is anti-clockwise. The original particle had no charge. That's true, because it does not have any track. Original particle was stationary, can be stationary. Why it cannot be stationary? Because if according to conservation of momentum, if final momentum is not zero, initial should not be zero as well. The original particle can be stationary if the two particles move in opposite direction, because if that shows that if original momentum is zero, the final will also be zero. So, and there is a magnetic field acting into that, you can not conclude until unless you know the charge. If you know the charge, which one is positive, which one is negative, then only you can work out the direction of magnetic field. Otherwise, you cannot work out the direction of magnetic field. The next question, electron can be used to investigate the atomic nuclei. Which of the following is not a reason why electron can be used to investigate the atomic nuclei? Which of the following is not a reason why electron can be used for such investigation? So when we check the statements, electron can be accelerated to very high speed, because which of the following is not a reason why electron can be used for such investigation? So if electron can be used like accelerated to very high speed, so we know the de Broglie's wavelength lambda is equals to h divided by mv. So if we increase the speed of electron, the wavelength will become shorter. As a wavelength will become shorter, the electron, which will behave like a wave, can easily diffract through the spacing and will observe a diffraction pattern. So electron can be accelerated to very high speed, that's true. Electron have a wavelength similar to size of atomic nuclei, that's also true, because when it's like the wavelength is approximately equal to size of atomic and investigating the atomic nucleus. So example, there's a nucleus is there, the neutron and proton. So we can use this electron which act like a wave and it will diffract. So electron can have a wavelength similar to size of atomic nuclei. That's also true. Can be changed. Electron has negative charge. So which of the following is not a reason why electron can be used for such investigation? So electron having a negative charge, this is not a valid reason for this investigation. Electron undergo diffraction. Electron will diffract when it is passing. If the gap size or size of the gap is approximately equal to the wavelength, then electron will have a maximum diffraction. So even though electron is negatively charged, but that is not the reason for using for this investigation. Others are correct, like if we accelerate the electron to high speed, it will have a shorter wavelength, we'll get a more detailed image or more diffraction will occur. In question 10, some Rutherford alpha scattering experiment used radium as a source of alpha particle. Which of the following nuclei would be produced by alpha emission from radium? So whenever there's an alpha decay, atomic mass will decrease by 4 and atomic number will decrease by 2. That's a equation. So we have radium is there. This is 226 and 88. So when it releases alpha particle, the nucleon number decreases by 4, so 222. And this 88 will change into 86. So 86 is there. The RA will change into RN. So C will be the right answer. Which of the following is not a lepton? So lepton family, what are leptons? We have electron, electron neutrino, tau, tau neutrino, muon, and muon neutrino. And same thing, positron, anti-electron neutrino, anti-tau, anti-tau neutrino, anti-muon, and anti-muon neutrino. These are like one of them are particles, the other are antiparticles. So which is not a lepton? Electron is there, neutrino is there, positron is there, but pion is actually a meson, a combination of quark and antiquark. So question 11, C will be the right answer. Question 12, the photograph shows a track of a positron in a particle detector. There is a magnetic field perpendicular to the plane of a track, but they did not mention in or out. Which of the following is a correct statement? First, what will the direction of the motion as a particle enter the track, enter the region? So it will collide with other particles and it will lose its energy. So this will be the movement of this. Now using this movement, I can work out the direction of a magnetic field as well. How I can work out the direction of a magnetic field? So it's a positron. So positive particle, my index finger, the first finger, represent the direction of magnetic field. The second finger will represent the direction of the particle. And thumb automatically will represent the force, the deflection. So in this case, the particle is deflecting in this manner. So that is the direction of force. So when you apply the rule, if you consider if the magnetic field is into, we don't know it's in or out. We know it is perpendicular, so either it can be in or out. But we don't know what is the direction. So when we apply the index finger into and second finger represent the direction of the particle, thumb is pointing in this manner. So if this confirms that the magnetic field is into. Otherwise, if the magnetic field was out, then how the particle should deviate, it should move in this out. So when we check the statement, which of the statements is not a correct statement? The energy of a positron is decreasing. That's true because when it collides with a particle, it loses energy. That's why it's energy. So the energy as a particle moves from one place to another, its energy is decreasing. The magnetic field is into when we apply the left hand rule, we'll work out that that's true. The magnetic field is into. Positron is gaining mass. The positron does not gain any mass. How we conclude that? Because the thickness of the track is decreasing. And speed of the positron as it's losing energy, so speed is also decreasing. The positron or the particle can gain mass if it moves close to the speed of light or relativistic speeds. Like closer to 3 exponent 8, the mass of the particle does not remain constant, so it increases. We call that as relative mass. So when the particles are moving slower, their mass is known as the rest mass. But in this case, what happened? as the positron enter the detector, it or a track detector, it collide with the particles inside, loses energy, so it slow down. It's the magnetic field is into according to when we apply the rule, and the speed of the positron and energy of positron is also decreasing. So option C will be the right answer. In question 13, baryon and meson are the type of the particle that consist of quarks. Which row of a table shows the quark composition for baryon and meson? Baryon means combination of three quarks. All should be either quarks or antiquark. And meson means it should be a combination of quark and antiquark. So when you check, this cannot be meson because so either B can be an answer or D. But B is actually combination of quark and quark. D is quark and antiquark. And baryon, three quarks are there. Any combination of three quarks, it's called baryon. So D is the right answer for this question. Which of the following is not a fundamental particle? So a quark family and lepton family, like if we have quarks or we have leptons, these are fundamental. What quark consists of? Up, down, top, bottom, charm, strange, and they're anti as well. But lepton consists of electron, electron neutrino, tau, tau neutrino, and muon neutrino. These are the fundamental particles. So electron is a fundamental, neutrino is a fundamental, quark is fundamental, but pion, which is a meson, which is a combination of quark and antiquark, not a fundamental. Quarks experience strong nuclear force where leptons are experiencing weak nuclear. In question 15, in early 20th century of experiment was carried out to measure the scattering of alpha particle as it strike the thin foil. Which of the following could not be concluded from the results of this experiment? Like, which one is not a valid conclusion of this experiment? Nucleus contains most of the matter, that's true. Nucleus is made of proton and neutron. That cannot be because what happened when most of the alpha particles are able to pass through, few of them deflected. So this gives an evidence that nucleus is charged, but this does not give an evidence that nucleus specifically contain proton or neutron. It only gives an evidence that because alpha particles are deviated or deflected, shows that there are like charges which try to repel and cause a deviation for alpha particles. That's why B is not the valid conclusion. Nucleus is charged, that's true, and nucleus is much smaller because most of the alpha particles are able to pass through, so size of nucleus is very small compared to size of the atom. In question 16, kaon decay into a pion into leptons. Which of the following decay is possible? What we do first, we start with the conservation of the charge. So when we check conservation of charge, this is having conservation of charge. This one is not because -1, on the -2 on the right, -1 on the left. This one also conservation of charge. This one also conservation of charge. Then baryon number. For each baryon, the baryon number is +1, and for anti-baryon, for mesons, there is no baryon number for them. And they mention it is producing 2 lepton. So remember, if there is an electron, then there should be electron neutrino. If there is a positron, like the neutrino should be associated with that particle lepton. Like if electron is released, the electron neutrino is there. If muon is released, then muon neutrino should be there. So when you check the 2 leptons, like either A can be an answer, C the charge is conserved, D also the charge is conserved. When you check here the combination like muon and muon neutrino. Here muon but electron neutrino. Here electron and muon neutrino. So I mean this is not correct because the neutrino which is released must be associated with the previous lepton, like if there is the electron, then electron neutrino, muon, muon neutrino, positron. It can be anti as well, but associated the neutrino which is associated here should belong to the same lepton. That's why option A is the valid answer.